What's up, math scholars? We're going to learn about simplifying radicals today. We will learn two methods, and you'll get to pick your favorite method. The one method's called the perfect square method, and the other method's called breaking guys out of jail method. So one sounds more fun than the other, but you can make the decision on which method you like. So who's excited? Woo! All right. I do have a box here that kind of talks through a power form and radical form. I am asking the students to only write down what they're seeing in the blue square, because that's kind of the property we'll be doing today. I think it's called the product property or something. But basically, if you have a radical and you have two numbers that are products, you can split them both into their own radical. The key is that jail guard has to be the same for both, for you to be able to use this property. That little n. So if it's a cube root, they both would have to be cube roots if you split them. Okay? All right, so we are going to go ahead and just use that property I just discussed to multiply these together, put them under one radical together, and then simplify down. And we can put them in the calculator. So the cube root of 2 times the cube root of 32. Since they're both cube roots, you can put the 2 and the 32 underneath the same radical together. So 2 times 32 is 64. And that's a perfect cube root. That's actually on your list, if you do have your list handy. The cube root of 64 equals 4. You could also type it in, but the cube root of 64 would definitely just give you 4. So did you see how that worked? How I put two of these guys underneath the same radical, both them together? It's kind of like a product rule. All right, next one. These are both fourth roots. So I can put them all underneath one big fourth root together. I would take the 10 and I would multiply it by 1,000. So tell me what that would give you. I think 10,000, if you just count up your zeros. It'd be 4 zeros. I'm going to check myself though. So yeah, it's the fourth root of 10,000. And then we can go ahead and fourth root that 10,000 like we did yesterday using that special root button. And the answer is 10. Any troubles with that one? Okay, the third one. Both of these are cube roots, so same exact deal. They can go underneath one big radical together. And I can actually calculate out what 16 times 4 is. 16 times 4 is 64. We actually already saw that one. The cube root of 64 is 4. All right, this just is the chart that you already have been given. All right, I want to talk about what the word simplify and reduce means. Something I do want you to write down is if they ask you to simplify a radical, they want no decimal answers. They don't want you to just go to the calculator and type it in. They want you to literally simplify and factor out, I was going to sneeze, factor out the largest perfect square. Oh, excuse me. All right, so I'm going to do the same exact math problem 2 times. I'm going to start off by showing you method 1, and that's called the perfect square method. So the perfect square method is to basically factor the 12 down into 2 numbers, something times something, where one of those 2 numbers is a perfect square. So you can kind of look at your perfect square list and assess your options. I'm going to borrow Gabe's list. So like, could I factor down 12 into either a 4 or a 9 or a 16? I'm looking for a perfect square. What do you guys think? 4. 12 is 4 times 3. Does that make sense? So radical 12 could be written as radical 4 times radical 3. My goal here is having one of these two be a perfect square. The square root of 4 equals 2, so I just make that a 2, and then that's a radical 3, and that's the answer. So radical 12 written in simplified radical form would be 2 radical 3. That's called the perfect square method. You always have to factor so that one of the factors is a perfect square. Okay? If you love that method, you can use that all the time. So we do the same exact problem using what I call the jailbreak method. And it's more of a factor tree. If you like factor trees, you'll love this method. Here's my 12. So I'm going to break down my 12 into whatever two factors I want. I could do 3 times 4, I could do 6 times 2. I'll just do 6 times 2, since I did 3 times 4 in the last one. I guess it's time for me to tell my jail story. This doesn't make sense unless you've heard the jail story. This 12 is in jail right now. That's what the radical is. It's a jail. And there's a little jail guard that sits right here. What number is the jail guard? A 2. And basically what the jail guard says is, he says, I'm the jail guard, and to break from my jail, you need to have groups of 2. Because eventually this will be a 3, and you'll need groups of 3. Or maybe it'll even be a 4 or a 5, and you'll need groups of that size. Alright, so you continue making your factor tree, not necessarily until you're down to your prime numbers, but until you get a group. And a group is 2 of the same number. So these guys can be in my group. Now, when you get a group, they get really happy because they're like, yay, we can break out of jail. So they start running out of jail. But tragically, one falls in a hole and gets lost forever. The way we express our final answer is this 2 who broke from jail gets to be out front because he's a free man. But this 3 who could not get a partner to break out of jail is stuck in jail forever. That's how the jail method works. Did you follow? I personally love the jail method, and I'll tell you why. That perfect square method is awesome, except when you get a problem like this, and suddenly you have to factor this down such that one of your factors is a perfect 4th. And that's a pain. Do you know what I mean? But the jail method is easy, because you'll just break guys down until you find a group of 4. So it's fully up to you. We'll do the next few problems with both methods, just so you can kind of gain an understanding of both and pick which method is right for you. Okay? So questions on that one? Oh, by the way, you can use your calculator to check. The way I would check to make sure this answer is correct is I would type in 2 times radical 3, and I would see what it is as a decimal. It's 3.46. And then I would type in the square root of 12 and just verify it is also 3.46. That just makes sure you don't lose a factor along the way. And you remember to drop him in the hole. Alright, let's try square root of 28. We'll do it the first way first, and we'll do the second way second. You can decide which method you like. So the first method is using factoring so that one of the factors is a perfect square. So how could I factor 28 so that one of the factors is a perfect square? Luis? Right, because 4 is a perfect square. So she's going to go with square root of 4 times square root 7, I think. And then the square root of 4 equals 2. And the 7 just kind of stays in jail because he's not a perfect square. So that's the answer. That's method 1, using the perfect square method. I'll do the jailbreak method just to give you an understanding of that and a little more practice with that. So I'm not forced to go with 4 and 7. I can if I want to. I'll just go with 2 and 14 to prove you don't have to go with 4 and 7. You have more freedom with this method to factor however you want to factor. And then 14 is 2 times 7. And you're like, awesome! I found partners. My partners get to break out of jail, run out of jail real fast. One tragically falls in the hole and he's gone forever. So the group leader, he lives out front, and everybody who cannot get a partner stays inside. Are you getting an idea of which method you like the best? That's good. Why don't you try the next one all by yourself with whatever method you like the best. All right, how did that one go? You could have went with square root 5 times square root 4 if you were doing the perfect square method, and then your final answer is 2 radical 5. Pretty good. Do you have questions? Some people find this really easy, some people find this really confusing, so you just have to ask questions if you're confused. Let's go and do a perfect cube one before I send up my board buddies. I'm going to skip around a little bit to find a cube one. This one, 729. So suddenly, if you're a perfect square person, you have to be a perfect cube person. So I'll show you how you would do method 1. You would find two numbers that are both perfect cubes. Or, sorry, you'd find two numbers such that one is a perfect cube. That would divide the 729. So I have to cheat and look at Gabe's list because I don't have my perfect cubes kind of memorized. 27 is an option. Let's see if 729 divides by 27. Oh, it does. Awesome. So 27 times 27 would be 729. Oh, and that worked great. Since the cube root of 27 is 3, I'm getting this from my chart. This answer is 3, and this answer is also 3, so it's 9. That one was too easy. We got to find one that's a little bit harder. I'm just checking that we did it right with the calculator. Yeah, we're okay. Do you want me to show you, before we do find one that's a bit harder, I'll show you how to do that with my jail method. Since you know me, I'm a jail person. So with the jail method, I would basically be breaking down my 729 however I want it. So I just experiment in the calculator so I can get myself going. 729, I tried dividing it by 9, and it did divide. 729 is 9 divided by 81. I'm looking for groups of 3, because my jail guard said, you need 3 guys to break from my jail. I could break this 9 down into 3 and 3, but I'm not going to, and I'll tell you why. I know in my head that 81 is 9 times 9, and that can be my group of 3. So you don't have to actually group up prime numbers. Does that make sense? You don't have to go all the way down until you can't go any further if you can group up a larger number. So they're going to run out of jail as fast as they can, and everybody drops in a hole and disappears except the group leader. That's your final answer. But that's how you would do it if you were looking for a group of 3. You want to do one where you're looking for a group of 4? This could get fun. Let's find one where it's a 4th root. Yeah, I thought I had one. Ooh, a 5th root. Yeah, let's just jump to a 5th root. This will get fun. Alright, so if you're doing the perfect 5th option, you're going to break this down into 2 5th roots so that one is perfect. I'm looking at Gabe's options here. He's got 1024 as an option. Don't think that'll work. 243 as an option. Let's see if 1215 divides 243. And it does. So it's 243 times 5. And I'm using the chart. So this method is actually only beneficial if you actually have the chart available to you to find that number. The 5th root of 243 on Gabe's chart is 3. So that answer is 3. And then that answer would be the 5th root of 5. So I'll do it one more time with my jail method to show you how I could look for a group of 5. So I can start my factor tree with however I want to start it. I would just start by dividing by 5. Anything that ends in a 5 is divisible by 5. It's 243 times 5. 243 ends in a 3, so I'm going to try to divide by 3, and it does. It's 3 times 81. 81 is 9 times 9, and all these 9s would break into 3s. And then you can kind of see I would have a group of 5. Now here's where the method gets slightly confusing when you're keeping track of who's in jail and who's not. So all these 3s break out of jail, which is awesome. And these all fall in the hole and die. Just disappear. I don't like to use the word die at school. So this 3, he's out of jail. Some people tell me, isn't that 9 still in jail? And I tell them, no, that 9 was broken down into these 3s. So you don't want to look at those 9s anymore. You're only looking at the end of each branch. It's this guy that's in jail. Not all going to be that hard of finding groups of 5. You'll normally just be finding groups of 2 or 3. I want to show you the hard ones. These guys are probably. Alright, so I'm going to pause the video and we're going to send up some board buddies to try some of the. We'll do a square root one first. We'll start it easy. Alright, we've got some 6 board buddies up here and they're doing the square root of 54. They can use whatever method they feel most comfortable with. I'll finish my video. Alright, so I made my factor tree. This 3 gets to run out of jail. Unfortunately, his partner there falls in the hole. So that 3 is out of jail. And then these 2 can't get out of jail, so we kind of had a discussion in class that they'll remultiply together. Okay? Any questions from the audience? Let's get 6 more board buddies up here. This is also a square. Alright, I've got my board buddies up here. They've been up and they've left. Some people kind of stopped when they got to here, and I got a chance to discuss with some of them that 12 can be broken down further. You can either break more people out of jail if jail method's your method, or you can use your perfect square method to do it like this. But you can get a perfect square here. The square root of 4 equals 2, and then 2 times 2 is 4. So here's our answer, but I'm going to show you how you could have gotten that without having the slew of 2's on the board. I see all these 2's on the board. It's like I'm a 2 collector. What you can do, if you recognize the opportunity, is you can partner up a 4. So 48 is 12 times 4, right? The minute I got that 4 there, I was like, oh, I'll say that 12 is 3 times 4, and I'll just partner up the 4's. Isn't that cool? So if you can, partner up larger numbers so you don't have as many 2's floating around and little prime numbers floating around. So now the 4's run out of jail, the 1's in the hole, and that's your final. Okay? Questions? All right, it's time to find a perfect cube problem. Go ahead and try this one, people watching the video. I'll pause and you can try it. Video. All right. Making my factor tree, making my factor tree. I need groups of 3 in my factor tree today. Okay, looking for groups of 3, right? I found 3 2's. They're going to run out of jail as fast as they can. As they're running out of jail, everybody except the group leader falls in holes. Goodbye, you're in a hole. You died. I mean, you're gone. Goodbye, you're gone. You're in your hole. Okay, so here's how we express our final answer. We have this 2 who's out of jail. He's like, yay, I'm free. But then we have this 3 and 3, and they couldn't get enough people in their group. See how you have these 2 guys? They're both in jail. So they re-multiply together to get a 9. And this is something I'm also seeing my board buddies forget about. You have to tell them what type of root it was. It was a cubed root. So you do have to have that little tiny 3 right there. Make sense? We'll try one more cube root one, because it is getting harder as we're looking for more and more people to break out of jail. Any questions? You get it now? Okay. Me too. All right, this will be your last one of the day. I'm going to send up 6 more people. Where did you leave off? Did you 2 still have to come? Did you 2 already come? So 2 and 3. That'll be 5. That'll be fine. Unless somebody wants a board buddy and we can have... I got my factor tree. Hooray, we can find a group. We're going to run out of jail as fast as we can, and these 2 guys fall in holes. So this 5, he's out of jail, he's liberated. This 3 is real sad because he has to stay in jail, and I do need to remember to tell them it's a cubed root. So I've got some good news on the homework. The homework is all a bunch of square roots. We just wanted to teach you cube roots and 4th roots for the fun of it. So the homework is all square roots. It's just going to be the front side of the paper that I'm handing out. And thanks at home for watching the video.